My name is Vinny, and I'm a lead engineer at HashiCorp. Uh, I'm really excited to be working on a new product called HCP Vault Secrets. This is our new cloud-native secret lifecycle management solution. Before I dive too deep in the new product, I kind of want to talk a little bit about Vault and how we got here. So Vault was first released as an open source project. It's pretty straightforward to use, especially in a dev mode. It's a single binary. You can run it on lots of systems, lots of environments, but it does come with challenges since the users are responsible for operating it, the infrastructure that it runs on. So things like backups, upgrades, that kind of stuff, all sits on the user's shoulders. So we came up with a handful of features that we knew our enterprise customers were looking for, and we released Enterprise Vault. The operational model there is still pretty similar, though. Our users are responsible for the infrastructure it runs on, and upgrades, all that kind of stuff. So then we took this one step further and came up with HCP Vault. This is a fully managed offering from HashiCorp Cloud Platform, HCP, where it's basically a push-button deployment. A lot of the stuff that users have to worry about, like scaling, all of that are just drop-down configurations, truly push-button deployments. We even offer templates and things like that to be able to quickly stand up a Vault cluster. So we really like that model, and it lowered the barrier for folks to get in. But we kind of wanted to improve upon that model a little bit. So we saw how folks responded, and we decided to come up with an even simpler secret management solution, HCP Vault Secrets, where you can essentially come in and instantly start storing, managing, and retrieving secrets without the need to think about any infrastructure. Much more of like a serverless type experience. So today I'm going to walk through essentially how our system works, and we'll use a little simple demo to kind of step through what this might look like to integrate in a variety of workflows that you would see in typical development environments. So I put together a small demo app here, pretty basic. We use a pattern that we see in the wild quite a bit. We use environment variables. We have 3 of them here: API token, database user, database password. We do a little bit of validation here to make sure that those environment variables are set. And then we essentially log out some things that I would never suggest doing in production, but we'll make this go a lot smoother. So if you look at the simple demo, it does exactly what we expect. Our log message using API token, using our database. That's all great. So let's hop into HCP Vault Secrets and see how we can move this simple application over to our new service. Within HCP Vault Secrets, this lives on our control plane in HCP, and you'll see that I already have a couple projects provisioned for me. Projects are the highest level in HCP where we apply user RBAC, role-based access. So this is like a great way to isolate groups of users and maybe environments, things like that. So here I have events team dev, which is a brand new provisioned project. In here you can see I have no active resources or anything like that. So clean slate. And we'll jump into Vault Secrets. So when we land on a new project here, we'll see that we have some call to actions, but simply our first thing is an application. So an application is our group of secrets, group of sensitive data, a workload that shares this common set of sensitive data. So I'm going to call my application events API, and I think API is a maybe not the best description for my demo app, but we'll use it. So once we get in here, you'll see we land on another clean slate, and we're going to add some secrets. So pretty basic. Essentially, we can just steal our secret names here. Save these. Perfect. Finally. So boom, just like that, I have an application. It has all of my secrets in it, and we're essentially off to the races. We've centrally located all these secrets, and we can start using them in code. Before I jump too far into that, I do want to talk about how this domain model looks for a slightly more complicated project. So at the top of this chart here, you'll see an organization denoted by this Vault symbol at the top can have multiple projects. And like I mentioned, that's where you can isolate resources. So you can isolate any HCP offering inside of a project. And then within projects, you can have apps. Within apps, you can have secrets. And within secrets, you automatically get secret versions. So every time you change the value of a secret, a new version is created. You currently cannot destroy versions. So it's this kind of always forward-looking, serving the newest version while never erasing history or any access control audits, that kind of thing related to those previous versions. So this is great, but let's talk about how this actually flows through our system. So this is our simplified view of what HCP Vault Secrets looks like in our control plane. I mentioned serverless earlier, so I assume some folks are thinking about how we keep everybody's traffic separated. That probably clued folks into this is a multi-tenant architecture, and so that means we need to secure customer data, and that's kind of the name of the game. So on our left side here, we have our control plane, and our right side, we have our tokenization service. So this is essentially how we separate things, and we'll follow a call through our little flow here. So essentially, this part's pretty basic. Traffic comes in, load balancer targets Vault Secrets. This is our entry point. From there, we rely on the control plane, so a centralized HCP construct to do things like authorization and authentication. And then immediately we start building an audit log. So every action that is carried out against secrets that live in HCP Vault Secrets will have audit entries attached to them. These audit entries are surfaced in the UI and provide details like how a secret was accessed, who accessed it, all of that kind of stuff. Then we have a metadata storage for Vault Secrets itself that lives in the control plane. This isn't anything super interesting. It essentially just powers the underlying service. So we'll move along to the exciting part here. Tokenization. This is how we encrypt user data. Also how we decrypt it, and we do a couple other specialized functions. This lives in a totally isolated environment. So you can see that we issue these short-lived sessions, and that is the only way to communicate with our encryption service. And in here, let me back up one slide here. On the left-hand side in the control plane, a tenant is considered like a project. So everything is scoped to that project. But in tokenization, we generalized it where a tenant can be anything. So we can have extremely fine-grained tenancy there, which then essentially cryptographically isolates resources however we see fit when we interact with this service. So when we're dealing with tokenization, the it's kind of like a multi-step process to even interact with it. When tokenization first sees a new tenant attempt to make a request, that tenant needs to be registered. During the registration process, the tokenization returns a private ID. So now you have this public ID, which is in Vault Secrets case, an application. So that's how we kind of cryptographically isolate things. An application shares the same public and private key, but adjacent applications will all require different cryptographic material to encrypt or decrypt secrets within there. So anyway, so a tenant is registered within tokenization. A private ID is returned, and this private ID is required in a conjunction with the public ID anytime you make any request into tokenization. So these granular public tenants really allow us to build a very, very secure storage mechanism for all of our tenants' data. So end-to-end, everything is encrypted at rest. This is an additional layer on top of that, and how we keep customer data separate. Our keychain is derived by an AWS KMS key, and the actual tokenization workers are only kept online for as long as they need to do whatever request is coming in. So sensitive data never really lives very long in any of our systems. Essentially just the amount of time that is required to fulfill the requests, whatever that might be.
Vinny, may I ask a question before you move on? I'm trying to understand your tenant concept here. So I'm going to ask a question designed to hint at that. Can the AWS KMS key be a multi-region key? Do you care? You know what I'm saying, right? Can I have my tenant span to regions and use a single key for HA or whatever is necessary?
In this case, the key is controlled by HCP. So this is what we use to derive our keychain that encrypts customer data.
It's not a CMK in that case. Okay.
Right. So currently we're the one providing the KMS key. And yeah, so we have a lot of, I can't talk super in depth as to all the steps that we take to distribute that and protect it and everything. But for the most part, essentially, we're using that to encrypt all customer data. And I'm probably going to plug this a bunch of times throughout, but we do have a beta program. HCP Vault Secrets is in beta, and we also have an early adopter program where we seek feedback for features that customers might, see important. So if something like bring your own key is important, highly suggest that you hop in and leave some feedback.
At least a single region CMK, right? You know what I mean? Right?
Yeah.
Because legally, I may have to own that, if you know what I mean, right?
Yeah, so certain compliance kind of issues. Those are some of the interesting kind of workflows and problems that we're hoping to grow into as we mature out of a beta product. And like I said, any feedback as far as the how you see a centralized kind of cloud native secret management tool fit into your workflow. Definitely looking forward to making those a reality.
Thank you.
My question is that what does tenant mean there? Are we talking AWS tenant? Are we talking tenant on your end? Is it a subset of something? I'm only familiar with it from the cloud world. So
yeah, no, that's a great question. So I'm talking about a tenant here as how we define groups of data. So within this system, a tenant is, like I mentioned earlier, tokenization, we built this encryption, decryption service to be really flexible. So we can define however we would like to group data. And it's sort of like a trade-off between efficiency and not having a huge blast radius if something sensitive data were to escape or something along those lines.
Yeah.
So tenancy in our model is for HCP Vault Secrets. For when a user is entering sensitive data would be an application. So does that answer your question?
It does. It's something on your side. It's
correct.
A tenant within your offering. So thank you. That was really helpful.
Yeah, absolutely. Cool. Okay, so I've sort of talked about how we protect everything and how requests flow through our system. So we can get back to our demo and kind of see like how you would actually use this in the wild. So we have a CLI tool that a local developer can use to interact with secrets, and it's available on most package managers. I used Brew to install it. Its name is VLT or Vault, and we can see the version here. So you can kind of see that it is pretty basic. We can do some help. So essentially, to do anything with Vault, we need to log in. So we need to associate this CLI tool with my HCP login. So if I simply do a Vault login, we'll do a quick OIDC flow, and we'll see that we're successfully logged in. From here, I can do a Vault config init, and what config does is essentially prepares this repository to be associated with a particular app in Vault. So if I give it the local flag, you'll see I have a couple, my user is privileged in a couple different projects. So I'm going to stick with the dev project. And from here, I only have one application right now, so I'll do that. And you'll see that I made a local file here. So super basic. This can be committed to source control. It has no sensitive information. It's just pointers to kind of help the CLI tool along. So with this, we can basically do, let's see here. So if we're going to run our application, we have a subcommand called run. So if I look at the help here real quick, pretty awesome. The most powerful part about this is the -- command, which is essentially a supervisor, wrapper, or whatever you want to call it. So if I just do vault run, Python 3. You'll see that I pulled down my secrets from HCP Vault Secrets, piped them into my API, and off to the races. No sensitive data on this system at all. If I were to lose access to my laptop or something like that, all of this is pulled at runtime. And this same concept of using Vault Run as a wrapper can be used like in containerized workflows, all sorts of anywhere that that a wrapper type approach makes sense. And we have lots of docs about integrations and things like that of how to get started with this. Cool. So next thing I want to talk about is secret sync, which is another extremely powerful feature that we decided to include in our beta offering. And essentially, the environment variables are a great way to do things. We see it often in the wild, but sometimes you, for a variety of reasons, you might not want HCP Vault Secrets to be facilitating your last mile delivery of secrets. You might be interacting with services that can't handle environment variables or that wrapper type construct. So what we came up with is sticking with that theme of having Vault Secrets be the source of truth. We sync to destinations. So we can essentially take an application's secrets in HCP Vault Secrets and push them to a third party. So in this example that I'm going to run through in this demo is we're going to push them to Secrets Manager. And then from Secrets Manager, your developers, if they're already using that, would essentially see no changes in their workflow. But HCP Vault Secrets becomes your centralized secret repository. You're getting access details, all of that kind of stuff, while all your developers are just happy with no changes. So to do this, you'll see if we cruise over to our application on the left-hand side, after an application is created, we have this integrations here. And under integrations, I can add AWS Secrets Manager. So I'm going to say that this is our events sync AWS dev. So I'm just going to give it a generic destination. This is just like a name inside of HCP Vault Secrets so that we can determine what, one integration from another. I will copy this external ID, which this is a specific way. What I'm doing right now is I'm going to run some Terraform. There's a couple other ways that you can provision this. But essentially, we're establishing a trust between HCP Vault Secrets and my AWS infrastructure. And because of that, we want to have a couple checks and balances. And you can read through either our documentation or AWS's recommended security docs to learn more about how this external ID works. But essentially, it establishes this check and balance that you would also require this unique identifier to be able to do things on behalf of this role that we're going to create. So I've copied this. I'm gonna hop over here, do some, I can pop open this Terraform. You'll see it's actually quite easy. We're using the AWS provider. The external ID is what I just mentioned. We'll paste that in as a variable. And then we're gonna make a role. This role is to allow the secrets worker inside of HCP Vault Secrets to assume a role inside of AWS. And then from there, these are the permissions that we are granting that user. So if I do a quick Terraform apply, I will paste in my value. You'll see that I'm just adding this role. And my output is the ARN of that role. So if I hop back over to Vault Secrets, I'll paste in this role. AWS Secrets Manager is a region-specific offering. So I choose what region for this example. I'll do US East 1. Currently, we offer US East 1, US East 2, and US West 2. So again, you'll have an opportunity to join this the early adopter program. We're always looking for other inputs as far as where we should sync to, both as far as integrations go, but also as far as regions and things like that. So once this one simple setup is done, I land on my status page here. You'll see after just a couple seconds, all three of my secrets were synced. So if I follow this link here straight into AWS Secrets Manager, you'll see these are all where we expect them to be. I can zoom in a little bit here. So that is Secret Sync. And now to kind of show how this entire thing works end to end as far as being the source of truth and a central repository, if I see that my API token is a token, I'm going to edit this to be live demo. I will save it. Oops. In here, I will, again, run my lovely Python 3 API. You'll see that I'm using the API token live demo. And if I hop over to AWS Secrets Manager and close this and retrieve it again, you'll see live demo. So essentially now I can use HCP Vault Secrets as my centralized source of truth and have it both operate in a push and pull model, depending on how my workflow is designed, and essentially with minimal code change to no code change, move all of my secrets over here and be off to the races.
So is that, I'm sorry, Vinny, I just want to make sure I got it, put it all together. So in the IAM role that you created in Terraform, you added the ability to rewrite the secret in that role, correct? I didn't see it go by.
Correct.
So it's update secret, there it is.
Yep.
And are these versioned at all?
Yeah, absolutely.
Okay.
So within our UI here, you can drive into a particular secret to see the versions. So you'll see that I was the one who updated both of them. I can retrieve previous values. So this is my first. This is my second. And then also at the app level, you can drive into activity logs. And this will actually show all of the activities that were performed against this this application, including secret level details when they were added. When this force sync here is when they were originally synced to AWS. And then these are some of the follow-up actions that were performed. And then you can also see what the interface was that performed that action. Essentially, we're in beta right now, and we would love for everybody to come check it out. We have some great documentation at developer.hashicorp.com. You can also give this a try. We have a free tier, and it is quite generous to see how this would work in your existing workflows. And like I mentioned earlier, we also have an early adopter program, and this is really crucial for us to get feedback from users like yourself, everybody viewing this content, to help drive where this product heads in the future, the various things that we can implement in it, the feedback about features that we've already developed. And yeah, really looking forward to seeing this grow with everybody.
The difference between Vault, if I deploy full-blown Vault and Vault Secret, is?
Yeah, great question. And so essentially the main difference is the cluster versus clusterless. So one is not necessarily better than the other, but clusters need to live somewhere specific. And for some workloads, that's really, really good. For other workloads, that's like extra trouble that a user might not be interested in. And we saw a growing trend of folks looking for these cloud native tools. So that's where HCP Vault Secrets fits in, being a clusterless solution, kind of working through that serverless type idea. For other industries, having a specific spot that a cluster lives within your infrastructure, or something like HCP Vault, where it can establish trusted networking with your infrastructure, that is the better option.
Okay. And is this going to be, it's early adopter, it's beta phase and all of that. Is the ultimate pricing and how it's going to be structured worked out yet?
Yeah, you can learn more about that on the website on HCP. And right now it is in free tier. We do have plans to move this to standard pricing and that kind of stuff. I can't really talk too much about that, but I think that we'll have some announcements in the near future.
Okay.
And I can add to it. I'm a product manager in the HCP Vault Secrets team. Certainly, we are happy to talk through pricing as when we reach out to you, or you feel free to reach out to us, happy. But at this point, as Vinny said, we are in beta phase and we are looking more for feedback, and guaranteed we have to go through the motions of pricing, packaging, as well as the general availability of this product down the road. But happy to certainly talk one-on-one.
So my other question is, I know it's in beta. Is that the reason there's only one cloud provider mentioned there? Or there's only AWS? Is it because it's only in beta right now?
Actually, we are going, what you can see is continued integrations from us during the beta period.
Yeah.
It's just the start.
Yeah. That's a good answer to that question while you're in beta. So that's good.
So you'll sync to the Azure Key Vault,
Yeah, subsequently, yeah.
GCP, KMS, stuff like
Yeah.
that, right?
All the top cloud providers are
It would
super
make sense,
important.
right?
Yeah. Yeah.
But you run on AWS. This is hosted on AWS?
The way I'd frame this as HashiCorp is a cloud. If you think about like Snowflake or anybody.
We shouldn't care.
Yeah, I mean, it should be transparent to our end users. That's our goal.
We shouldn't care except that you're holding our secrets, so we probably should care. Right?
And that's why we certify HCP as a platform with, let's say, ISO 27001 or SOC 2 Type 2. So from that standpoint, we'll give those, kind of
correct
regulations. Yeah.
And I'm sure there's data sovereignty questions you get because you're running on a cloud about which part of which cloud.
Yeah, which.
So,
Yeah, which,
I mean, I don't need an answer to that, but yeah, those are the types.
Country at a minimum, right? Which
yeah,
country?
exactly.
Yeah, I'm stuck on the legal thing of you owning the KMS key. So if you read AWS's user agreement and Microsoft's user agreement, they both waffle, I think. I'm not an attorney, but they both waffle on the question of whether or not, for example, a Patriot Act court order would require provision of the key, right? So some organizations, including some that are heavily regulated organizations, their legal department will say that you cannot use a product where we cannot be involved, where we may not be involved in notification, because the government has to go to the owner of the key, right? So we must at all costs prevent the cloud provider from being subpoenaed in what, in the United States at least, can be a secret court proceeding for the production of records, right? So I just want to give you that as, you're a product manager, I want to give you that as a potential market requirement, because it's a very serious thing. If you want to deploy, you want to go into production. I mean, for dev, test, people may not care, maybe even UAT. But at the production level, we're no longer talking IT, we're talking the lawyers.
So they'll offer you the managed HashiCorp Vault offering on your infrastructure, which they'll manage for you on your behalf for dollars per hour, right?
Yeah, but I thought Vinny said that the tenant had the KMS key and it was your key.
This is HCP.
Your tenant.
This is the HCP cloud offering for people who don't want to manage instead of infrastructure. I think if you really had those needs, I suspect we would just pay you to do a managed vault or do it ourselves, right?
Yeah, that's certainly an option. Doing it yourself is certainly an option. But at the same time, the feedback that you provided is well taken. Certainly, we will look into this a little further along the lines of legality.
You got to think hard about the, some will require actually an HSM to provide the key.
Great feedback. Yeah.
Right? That's a really, I know it's a small thing where,
but it's necessary,
it's 256 bits, but it's everything when it comes to production of data, right? Or production of secrets that give you access to encrypted data. You know what I mean? You got to start somewhere, and this is the top of the chain, or the root of the tree, or whatever you want to call it.
Pete, were you going to say something?
I was just going to ask.
It's not really root of all encrypted.
I was just going to ask a clarifying question on that front, just around like the particular use cases for Vault Cloud Secrets, especially as it pertains to the root of trust question, whether or not, what is there specific use cases maybe where it's right to use Vault Cloud Secrets, or it's right to use, I guess, traditional Vault or managed Vault, whatever we're calling about. Because I think that root of trust question is one that brings to mind where different scenarios where that's a relevant concern. Maybe the answer is the more managed Vault today.
And if you think about smaller startups or companies that are getting started towards the journey on the cloud side, and they want to have a best-in-class secrets management for the application developers to get started in seconds, not even hours, minutes, in seconds. HashiCorp Vault Secrets gives them the good jump start of, don't worry about what is Vault, just worry about your application, put your secrets and keep going with the same developer tool flows that you're used to.
Is there a migration path to go from HCP secrets to self-hosted or the hosted platform that you guys do where it's your own tenant?
It's a great question. Certainly, it's in our roadmap horizon. Again, maybe offline we could talk more about what we are thinking in terms of roadmap. But certainly, we did think about that. Yeah.
If I may, I just want to respond to that comment about speed. You know, no disrespect, but speed and security are not necessarily the same thing. And I think we all know that developers are always talking about speed many times as an excuse to not do the right thing.
Yes.
Right? So it's up to our tools to help them do the right thing. And I'm not sure that the number one marketing benefit of a product that's about security is necessarily speed. You know
You're
what I mean?
absolutely right.
It's good to be easy to deploy, and it's good to be functional, and it's good to be easy to use. But it also needs to really sort of check the security box, if you know what I mean. I'm just trying to give you a
No, you're absolutely right. In fact,
little bit of feedback.
Yeah, this is a great point. One of the discussions that we had, and I'll circle back to your comment, was when we had the initial thought process about the product, we said, as you said rightly, we realized that development agility and security first approach don't go together. There is a trade-off, there is a balance. That's your point. So we said, what if we change the trade into not or, but and? You can have both, and, not or. What do I mean by that? Vinny talked about the centralization of secret manager and the syncing. The whole purpose we created the syncing is because the secret sync that Vinny talked about is because developers may want to get started quickly with the native, for example, AWS SDKs, and get started with using the AWS Secrets Manager. That's fine. What we are saying here is as long as we are able to sync and make it as one centralized point of control and be able to rotate from the centralized point of control, now you get the benefit of that secure first approach. So when we talk about speed, yes, that is one aspect, but certainly from the other aspect of centralized secrets management addresses the feedback that you were talking about. So great one.
And I would just add on that. I know I'm primarily the boundary guy, but just from kind of a philosophy.
Respect your boundaries, in other words.
Yeah, exactly.
Just kidding.
No.
Very bad.
Right. But I think across these different use cases that you said, like the specific one around the ability for a federal entity to be able to get a subpoena over access to a managed service, to be fair, that's a use case and a design constraint for certain solutions that not all organizations, not all developers are going to want to design for from the ground up. Certainly, like core security, we're building into these products and into these offerings, but for that level of constraint, that's not something that's a day one problem. And there are other offerings within the Vault portfolio, self-managed Vault that can solve that particular problem.
Yep.
So I would just say, like, that's these are design considerations. It's not like a fully speed over everything or security over everything.
Yeah, I
it's the
hear
right
you.
tool for the right situation.
I mean, I know I don't want to push back. I don't want to push back because I respect the argument. But if I'm going to get a developer to deploy an IAM role in Terraform, who really, besides that developer, is going to know what Vinny showed me, which is the ability to update the secret? You know what I mean? Then I have to audit whether they've, you know what I mean? Whereas with Secrets Manager, I can just apply a policy, an AWS managed policy, to Secrets Manager that's going to prevent that, because you have two-way sync, which is a cool thing. But it means that the developer who's working in his world, in his, code world, has too much control over those kinds of secrets, if you know what I mean, right?
Again,
it was really easy to do, and it's really cool to show, and it's kind of insecure.
Yeah, so this is another great point. There's another side to this story, and I want to be respectful of the questions for boundaries, so that I'll try to keep it as short as possible.
You're respecting his boundaries now.
Yeah.
Oh, all right. Okay.
So that's a very good point that you brought up.
Two more.
That's two.
And in isolation, this makes sense. Now, if you think about the same developer going to, let's say, multiple applications like GitHub Actions or Vercel, you keep naming names of different syncs where those secrets are getting added there. Now you are creating a secret sprawl.
Yeah.
So at some point we have to, there is always going to be some kind of a discussion around which is a better option. When you get into a secret sprawl situation, am I better off centralizing it and giving access to one point and being able to control from one point and rotate from one point. So
I hear that argument.
So yeah.
Yeah, I hear that.
I'm wondering if we have a project where there are 5 different companies that are going to cooperate. Each of them have their own Azure tenant with their own MFA setup.
Sure.
Can you use Boundary to facilitate the authentication from all these organizations for a set of users for each of them?
Yes, you can. So this is one of the key capabilities of not only Boundary, but also Vault has the same capability. We call it identity brokering. Basically, the core idea is that you can have a logical identity within the service, within Boundary or Vault. With Vault, it's a logical identity entity, which can be like a service account. Within Boundary, it's typically a human user. And then you can have multiple different accounts that logical identity is associated with. Those accounts can be rooted from an auth method. That might be, Azure Active Directory Instance 1. It might be Azure Active Directory Instance 2. It might be LDAP on premises through AD instance 1 through N. Ultimately, you can have as many different auth methods as you want, and you can configure this IAM topology to allow a user to log in with any of their particular auth methods across that landscape. It's very key for organizations that might grow through different acquisitions where they have different technology stacks, or organizations that give autonomy to different business units to make different technology decisions. The other thing that we always recommend is that for something as critical as infrastructure access for your SREs, that's maybe not in the hot path of your application, but it is really like a day one system, right? Like that you oftentimes need to access infrastructure to respond to incidents. We always recommend having multiple auth methods to log into Boundary with, because you need some recovery workflow in the event that AAD is down, or in the event that Okta is down, or something like that.
So is the user the sum of the accounts associated with it?
Correct.
It's always the sum.
Correct.
So all claims are summed.
Correct.
Additive.
Well,
zero trust.
So the user is a logical entity, right? That user can be the sum of the different accounts that can authenticate that user, right? That user is added to different groups and roles within Boundary. Those role memberships are what governs the actual access itself.
And the roles are additive for all users and all auths.
The roles have grants. The grants are fully additive. We do give intelligent defaults that you can add people to, but a role without grants is a zero trust. There's no concept of permissions.
The groups use attributes for the logical user. Those attributes of the user are mapped in through the authentication.
We call those managed groups, but yes, they use attributes from the particular user. I know we're back at the Boundary portion.
Got it. And you can
cross the border,
change the attributes of those users, add to them as you go, and then the managed groups will still be based on those attributes of the logical user.
It's an excellent question. So the core idea for configuration, we've got a whole set of tutorials and documentation on this, but the key idea is that different identity providers will mint different permission claims as part of the JavaScript web token that gets exchanged as part of the OpenID Connect protocol.
Right.
So it's important on the identity provider side that you're including the appropriate information in that JOT if you want to use that for access decisions in Boundary. If the identity provider does not let client applications know about that business context, there's nothing that we can do. That's the OIDC protocol.
If they don't come across, then your searches are not made, you don't have that.
Exactly.
Then obviously your managed groups can't pick those up off the user identity.
On the actual managed group within Boundary, a configuration setting is an administrator-defined filter that basically says add any user with this metadata, and it's the filter language is Go, BXPR. It's used across the HashiCorp portfolio and in a number of places.
So it's dynamic in the group in Boundary.
Correct.
And what about dynamic groups in the identity provider? Are those claims refreshed?
So again, when they log in, so long as those claims get issued as part of that JavaScript web token, we can bring those up. Yes.